Again, welcome to Pre-Calculus class, Mathematics 164. This lecture covers sets. Our main objective is to describe what is a set. Also, we are going to learn how to perform set operations and also how to use the Venn diagrams. So a set is a well-defined collection of objects. And there are two ways to tell what a given set contains. One way is by listing the elements or the members of the set, usually between braces. So for example, here we have set A. Set A have elements of 1, 2, 3, 4. And also here we may say that again, set A contains 1, 2, 3, 4 by writing A equal to the brace 1, comma space 2, comma space 3, comma space 4. Or there's another second option. To say that 4 is a member of a set, we can write 4 belongs to A. So the symbol here means denote or belongs. Similarly, we write 5 not belongs to A. Or we can say 5 is not a member of set A. So again, we can use the symbol 4 is not A, or 4 is A, or 4 is not A. Now, if all the members of a set can be listed, then we say the set to be a finite set. So example, set A, 1, 2, 3, 4 is a finite. Set B, X, Y, Z is a finite set. Now, if we have a set that cannot, all the elements cannot be listed, then we have infinity sets. So it will be 1, 2, 3, 4, then 3 periods, which means it's infinity. So we say an infinity set, we cannot list all the elements. So we use the 3 dots. So for example, n equal to 1, 2, 3, 4, and the 3 dots here means it's infinity set. And in this case, the n is called the natural numbers. Natural numbers normally start from 1 to infinity. Now, another way to specify the element of a given set is by description. So for example, f equal to y, where y is an odd natural number. So this will be reading as f is the set of all y such that y is an odd natural numbers. So odd natural numbers will be 1, 3, 5, 7, 9, then 3 periods. Natural numbers are infinity. Now, let's see the first example here. Here, describing a set. So write the following set in 2 ways. The set A of a natural numbers less than 6. So here we are saying that set A consists of numbers that are less than 6. Now, since it's a natural numbers, we are going to start from 1. So our answer will be 1, 2, 3, 4, 5. 5 is less than 6. Or we can write it that set A is X element where X is the natural numbers less than 6, or A equal to 1, 2, 3, 4, 5. Now the second is set B of a natural numbers greater than 10. So which means I will start from 11, 12, then 3 dots, infinity. So let's see the result. So again, set B will be greater than a natural number greater than 10. So it will be 11, 12, 13, 14, infinity. Or we may say that X elements for B set, where X is the natural numbers greater than 10. Now, C said the set C contain only 3. So this means the set C have only 1 element, which is 3. Or we can write it C consists of S element where S equal to 3, only 1. Now, a set is it possible for a set to contain no members? Yes, it's possible. So normally a set with no members is called an empty set. Or sometimes we may use the term no set, and we can denote it by 0 with a slash, or an open and closed empty braces. So here again, we say the special relation that may exist between two sets are defined as following. So we have two sets. Set X and Y are equal if they contain the same number of elements and the same elements. So the size must be the same and the number of elements must be same. So for example, set X have 1, 2, 3, 4. Set Y have 4, 3, 2, 1. They are the same, S equal to Y. Again, the order of the element doesn't matter as far as we have the same elements and the size are the same, they are equal. And also we said A is called the subset of B, which means all the elements in set A also is in set B. So we say if every element of A is an element of B, then we will say that A is a subset of B. Now the empty set is always a subset of every set. Each set A is a subset of itself also. So here, for example, if A is 1, 2, C, F, and B is 1, 2, 3, A, B, C, F, we can see that 1, 2, C, F is also in B, but there are some elements in B that is not in A. So this means A is a subset of B, but B is not a subset of A. Normally, we can use the first symbol here. So something like a C with underline means a subset set. So here we say A is a subset of B. Now the third is if we have set C and D, and set C and D have no elements in common, then we say this is called a disjoint. So we can see that set C have 1, 2, AB, D have 3, BC. So they don't have any element in common. So this set C and D are called, or we will say they are disjoint. Now, in the discussion of a particular set, the assumption is always made that a set under discussion are all subset of some larger set. And normally we will call this set a universal set. So for example, if we use alphabets, the universal set of alphabet will be the characters from A to Z, both lowercase and uppercase. Because the universal set will be all the possible elements that can be contained in that category. And when we talk about alphabet, we only go from A to Z, upper and lowercase. Also, we may use the Venn diagram to illustrate the relationship among sets. So let's see how it's being used. So for example, we have a Venn diagram. The rectangle with the U means it's a universal set. Then we can see that B is inside A, which means B is a subset of A. All the elements in B are also in A, and there are some elements in A that are not in B. Now we can see the Venn diagram here, M and N are separate. So this means the set M and set N have no common elements. So they are disjoint. And X and Y are not disjoint because we can see there's some intersection between X and Y here, which means the shaded area, the set X and Y have common elements there. So now let's see the set operations. We can perform some arithmetic operations on set. So the first operation here, we say that we are using a Venn diagram here. We have a universal set and S and Y, and there's some intersection here. So as we said earlier, S and Y are not disjoint because there are some element that is common in both S and Y sets. And normally to find that element, we find what we call the intersection. So here we say the intersection of A and B is all the elements that is common in both set A and B. So let's see a nice example first. Next is the union. The union of two sets means all the elements in both sets. So the union of A and B written as A union B, saying that if S is the element, then all the elements in set A or all the elements in set B or both of them. So again, we're going to see an example in a few seconds. So this is the example for intersection. The Venn diagram will see the shaded area means all the elements in set A and B. And this will be a union. We want everything in A, everything in B, but we don't want a duplicate. So if set have element 1, 2, 3, if there's a duplicate 1, 1, 2, 3, we are going to remove 1 to have only 1, 1. So again, just a few seconds, we're going to see some few examples. Next is the set complement. A set complement means all the elements in the universal set that is not in that set. So for example, if we say that here we have A complement. A complement means all the elements in the universal set, but they are not in A. Now here we can use the Venn diagram to illustrate the complement again. Here is intersection. This will be a good one for complement. Here you can see that a complement of A means all the elements in the universal set, but it's not in A. It's not in A. Now, the best way to do this is to see some example here. Now, here they say many local newspapers list stocks of a local interest. Suppose that on a certain day, a prospective investor categorized 23 stocks according to whether their closing price on the previous day was less than $50 per share, which would be set C. Then their price to earnings ratio was less than 20, which would be set P. Their dividend per share was at least $1.50. That will be set D. So now our question is, of this 23 set, we say 16 belongs to set P. 10 belongs to both sets C and P. 12 belongs to set C, then 7 belongs to both D and P. 8 belongs to set D, and then 2 belongs to all the 3 sets. Then 3 belongs to both sets C and D. Now, based on this condition, we can come up with a Venn diagram. And the question said we should draw a Venn diagram that represents this information. Use the diagram to answer the following question. How many stocks had the closing prices of less than $50 per share or price to earnings ratio of less than 20? Also, how many stocks had none of the characteristics of sets? So this would be complement C, B, or D. Now, how many stocks had only dividend per share of at least $1.50? So let's see the answer. First of all, we know we have 3 conditions, sets, P, C, D. Then we have the universal set. Now, based on the question, we saw that 2, the 2 here is in what? It's in set D, and also set C, and also set P. Because here we say to assign the numbers from our data, we must begin with informations that refer to a single region, namely the 2 stocks belongs to all the 3 sets. Because this condition is given here. Let's see, the condition should be somewhere here. It's given to, okay, 2 belongs to all the 3 sets. So we start with that first. So we have it. Then next, we have 8. We have to be careful with the calculations. You can see that the reason why we put 8 here, because previously P have what? 2, C also have 2. So this means P and C together, they have 10, based on the question, the condition. Now, why we have 5 here? Because D also have 5 to 8, whereby P will be total, now it will be total 15, etc. So we just look at the conditions here and we assign all the values. So for example, here we say 16 belongs to set P. Then 10 belongs to both C and P. So 10 belongs to both C and P. We can see C and P. We can see the set 8, 1, and 2, 1, 1. So 8, 1, 1. That's only P and C. Now, when this 2 down comes in, this 2 belongs to order 3. So based on the condition, this is what we get. Now, if we get this, to answer the questions now, it's very straightforward. So B, we have 5 stock outside the 3 sets, C, D, and P. Also, those stocks that had only dividend of at least $1.50 50 per share are inside the D, but outside for both C and P. So there are no such stock. Again, based on the condition. And this question is very straight in the sense that the conditions given here is what we make sure we apply to the diagram. The Venn diagram is the best way to solve this problem. So first, I will start with the 2 belonging to order set. Now, if I know 7 belongs to both D and P, then within the D and P, I have to make sure the total there will be that value. Now, this will be only D and P, excluding what? Excluding C. So we have to be careful. First, it's good to start with we start with 2 because 2 belongs to order 3. Then if we get only 2, like PC or DC, etc., then we keep adding the values on the conditions. So that will be the conclusion of our first lectures in this course. The main goal here is to learn how to use, again, set operations and also to understand what is a set. So again, see you in the next lectures. Thank you. Bye.